And with that, I'm going to bring up Peter Yagecic.
Can you hear me okay? No, you can. Thank you so much. I'm really excited to be kind of wrapping up the day today with you all. The title of my talk is Bringing the Future into Focus. So hopefully in these last few minutes, what I'm going to be doing is looking for some of those frontiers that Tom mentioned that we're always looking for. As Damien mentioned, some of it just came back from South by, which is a ton of fun. I couldn't agree more as a good picture of us. I thought it would be fun to create a word cloud of all of the sessions that I favorited. I didn't get to go to every single one of these, but these are all the ones that I was interested in. And I wanted to pull some things out of here today to talk to you about some of the most interesting technologies that we saw there. And I think by far the most impactful technology coming out of South by were electric scooters. Actually, I'm kidding, but these things are very, very cool, and they're everywhere down there. Every street corner has like a pack of them, like they collect together. Damien actually rode his first electric scooter when we were down there. And it's really a great way to get around. They're in a lot of cities in the South, too. They're all over DC. But no, I'm not going to talk about electric scooters, even though I could. What I want to talk about instead are these three technologies and run through each of them quickly, tell you why we're really excited about them and the potential that they're going to bring for our lives and the work that we're doing. And those three technologies are 5G networks, which you've probably all heard about. I want to talk a little bit more about AI, artificial intelligence. I think Lisa did a great job teeing that up. I want to talk about one element of it in particular. And the last will be this concept of this mirror world of data that we're all living in that I'll share more in a minute. So first I want to start with 5G. So 5G is the next generation of mobile network communications that's going to be upon us very soon. We don't have it today, but it's coming. Starting in the 80s, we got 1G. And about every 10 years, we get another generation of wireless networks that gives us more speed and the ability to do more stuff. Starting in the early 2000s, we got 3G. And this was a really interesting point because this is when we started thinking about using these networks for data consumption as opposed to just talking to one another on the phone. You could actually pull up websites on your BlackBerry. I don't know if you remember doing that. They were really bad. They were really slow. But you could do it. And then when we got up to 4G, this is where things really kind of tipped over. We started using our devices much more for the consumption of data than we did for actually talking to one another. Who talks to anybody anymore? So what are we going to get with 5G when we get this in a couple of years? Well, it's going to be faster. For sure. If you Google image search, 5G speeds, you see this come up a lot, but it's kind of deceptive because if you look at it, it's like, oh, well, it'll be twice as fast. Well, thanks to Wolfram Alpha, I actually did some math and compared 100 megabits per second to 10 gigabits per second, and that's actually an increase of 100 times. So that's theoretical. I don't think we're going to get 100 times speeds on our phones out of the gate. If we did get those speeds, that would be 10 times what I have in my apartment with my Fios connection. But Qualcomm did an actual test in San Francisco where they did look at real-world speed today for 5G networks, and it's about a 23-fold increase. So that's pretty good. When we get these things out of the gate, it's probably going to be about 23 times faster. But it's not just about more speed, although I'll take that. It's really about a reduction in latency. So latency is the term that's used when you talk about the time it takes for one system to have a conversation with another system and get a receipt back. So that round trip is a measure of latency. How many people in the room are gamers, online gamers? I bet a lot. Okay, one or two, Mike. So if you're a gamer, you know all about low latency because you want really low latency when you're playing Fortnite or whatever because it gives you an advantage. Every move you make on the joystick is going to be faster and you can have an edge over your components. Well, that's great, but what about the rest of us? What does low latency mean for us? Well, self-driving cars are really going to benefit from this. And the reason being, this is a quote from Forbes.com. Our current 4G networks are fast enough for us to share status updates or to request our Uber, but they're really not fast enough to give cars those human-like reflexes that they're going to need to stay out of accidents. So that's going to be a huge benefit from this new network. Now, 5G is going to have some challenges. I don't want to pretend like it isn't. The first is going to be managing the hype. I don't know if any of you saw this. AT&T got into a little trouble for kind of jumping the gun a little bit with 5G. They started putting a little 5GE icon on the top of some of their phones. Now, those phones were not running on 5G networks because they don't exist yet. But AT&T said, oh, no, that stands for 5G evolution. That's like me saying I have a six-pack evolution. Not today, but maybe in a couple years. Thank you. And I love the fact that this quote from the executive says, we broke our industry's narrative. That's really good spin. The next challenge for 5G is going to be gear. Good news, we all get to get new phones, which is great. I like getting a new phone every couple of years, but it's more than phones. The 5G network uses something called the millimeter wave spectrum. So we're going to need whole new antennas and whole new broadcasters and modems in our apartments. And they're going to actually have to be closer together. We get this faster speed, but the range isn't as far. So that's going to be a challenge. And then the third challenge that I foresee is data. If you think you have a lot of data now, just hold on to your hats, because we're going to get a lot more data with these new speeds. It's going to be like a tsunami in a garden hose and Daffy Duck exploding in the sky. So we're actually going to have to learn how to build better databases to handle all of that. OK. 5G recap, real quick. It's going to be at least 25 times faster than 4G, probably more. We're going to have lower latency, which means that systems are going to have quicker conversations. Self-driving cars are going to benefit. Things like wireless VR are really going to benefit. And we'll all need new phones and equipment, but I think they're going to be dumber. And by dumber, I mean they're going to be lighter, they're going to be cheaper, they'll probably get more use out of their battery. And that's because the processing that has to happen in your phone today can be offloaded into data centers. So there's going to be more stuff generating more data, but it can be, those devices maybe will be cheaper and dumber. OK. Next item I want to talk about is artificial intelligence. I think Leisha did a really great job of talking about how we're working through this as an agency, how we're not letting humans out of the mix necessarily. But I have to include a picture of the Terminator. I think that's just mandated every time you have a deck about AI. It has to come up once. So that's our one time for that. But we are using AI in our everyday lives. Lisa mentioned we're using it in ad buying. If you sell tickets, if you're someone in the room that sells tickets, you might be using a chatbot to help you sell tickets, and that's incorporating AI. Conversely, you might be using AI to prevent ticket sales from bots that you don't want them to get those tickets. So that's kind of an interesting use in both of those cases. About a month ago, I picked up a book at the Amazon store called Prediction Machines. It was the Amazon store in Columbus Circle, and it was written by 3 economists. And it really unlocked a concept of AI that I thought was very interesting and I wanted to share with you guys today. And the thesis of their book is that artificial intelligence doesn't actually bring us intelligence, but instead a critical component of intelligence, which is prediction. And to explain why that's such a big deal, I want to go back and talk about math for a second. So math in the mid-20th century used to be really expensive for computers to do. This is an image from the movie Hidden Figures, and actually there's 2 computers in this picture, the human computer and the machine computer. And this movie does a really good job of talking about when machines were getting slightly better than humans at doing basic math. Now, arithmetic functions, or basic math, are actually at the core of turning analog things into digital things. So music, movies, spreadsheets, books, all human information. Math is the key to the digital revolution that we have and know today that's making us deal with all these headwinds that we've been talking about today. Coming back to AI and predictions, we're at a very interesting time for predictions. Predictions powered by AI are not just getting better, they're also getting cheaper. And better and cheaper machine predictions are going to change everything, and they're going to change our value of human prediction. How many people have the Waze app on their phone? Quite a few. This is an example that the authors of the book give as a machine it's pretty cheap. It's a free app. But it's also going to be a better predictor of how to get from one side of town to the other than a human is. And that's not a dig against humans. It's just going to have more information. It's going to know what the traffic is on the other side of town. It's also going to benefit from the millions of people that use it in a way that a human driver just can't in their lifetime. Now, I want to make an important point that predictions do not necessarily equal decisions. And I think Lisa touched on this very well. This chart is the anatomy of a single task. On the left, you've got an input that's powered by data. That input lets us make predictions, which is what we're talking about. Those predictions lead to judgments, lead to actions, and then from that action, we have an outcome that gives us more data that goes back into new predictions. Now, when we're talking about machine AI, we're talking about using the fact that machines are going to be better at predictions than humans. And I kind of just realized that this human looks a little bit like Lisa. That wasn't intentional. But if we keep the judgment and the actions in the hands of the humans, then we're just hopefully making smarter choices based on those predictions. So, in the spirit of talking about our favorite TV shows, I wanted to talk for a second about Quantum Leap. I loved this show when I was a kid. I used to dance to the theme song in my living room. And for those of you who aren't aware of it, Quantum Leap is a story of a time-traveling scientist named Sam Beckett who would go back in time to try to fix things that went wrong in the past. But every time Sam leapt into a new scenario, he had no idea what he was there to do. So that's where Al came in. Al was a hologram from the future who was connected to a supercomputer named Ziggy. Now, Ziggy would make predictions of what Sam was there to do. In this instance, Ziggy didn't know exactly what Sam was there to do, but he said there's an 81% chance you're here to help Sue Ann. So if we go back to our chart here, there's Ziggy making the great prediction. It allows Sam to take judgment and make an action. And then if he does the right action, he gets to leap to the next timeline. So that's fantastic. But there are times, and it's going to be increasing in our lives, where we are going to be more comfortable with machines taking those judgments and those actions. Here's an example of when we definitely don't want that automation. Ash Carter, who is the former US Secretary of Defense, has made a promise, and he stated publicly that in the military, AI will never be fully automated. There will always be a human being in the mix to figure out when to take action. So that's great. But, in lower stakes settings, automation is probably fine. This is an example of some automation that's been around since the 70s. This is a mail robot that started out in some office buildings in government way back in the 70s. And the way this thing actually worked, it was kind of like a giant Roomba. They would sprinkle a chemical into the carpet, and all this machine had to do was follow that chemical trail and predict if somebody was in front of it. It didn't have to do too much in the sense of prediction. If you watched the TV show The Americans, they had a lot of fun with this storyline. This is a guy who was really, really mad at the mail robot. But move forward to today, and Amazon has things like the Amazon Scout that it's testing right now in neighborhoods. So this is the same kind of machine, but it has to do a lot more in terms of predictions and judgments. It has to judge when it's safe to cross the street. It has to judge when your dog is coming down the driveway. It also has to decide how long to wait for you in front of the house before it goes on to its next delivery if you don't pick up your package. So these are the kinds of automations that I think are exciting. All right, so AI challenges. There are a few. The first one is privacy. As I showed you in the anatomy of a task slide, AI gets better with more data. Privacy, by its definition, GDPR, it restricts the amount of data that we're giving over to companies. So it's just a reality of the situation that countries that have a different relationship with privacy, like China, are poised and predicted to probably have an advantage when it comes to AI. De-skilling is another challenge. We saw a talk with Malcolm Gladwell about autonomous vehicles at South by, and he asked the question, what's going to happen to all the students in high school who take driver's ed right now? When we have driverless cars, maybe they should take an internet security class instead. I think that's a pretty good idea. But what happens when we're all on the road in these driverless cars and they break down and nobody knows how to drive anymore? I don't know. And then the last one I want to talk about is bias. So a few years ago, Microsoft released a chatbot onto Twitter, and Twitter taught it to be a racist asshole in less than a day. So this isn't just the bias of the people that are making the machines. This is the bias of the people that it's interacting with. Now, this was a couple of years ago, and I promise you, a lot of people are working on trying to solve this issue. So recap of AI. Machines are getting better at predictions, and they're going to overtake humans in the accuracy of those predictions. We can choose to hold on to human judgment and action, as Lisa suggested. We don't have to automate where it doesn't make sense. And as AI becomes cheaper, it's going to open up opportunities we can't even imagine today, just like cheaper math did in the 20th century. Okay, one last point on AI. It's not perfect yet. So I mentioned that I picked up that book, which I highly recommend, in an Amazon store at Columbus Circle. I used my Amazon Prime credit card. And then about a week later, a machine predicted that I might like that book from Amazon. So you can think that, we've still got some work to do on AI. All right. Final stretch, Mirror World. This is one that I am really geeking out about. This was based on an article that I saw in Wired last month. The premise of this article was that someday soon, every place and thing in the real world, every street, lamppost, building, and room, just like this one, will have a full-size digital twin in the mirror world. And that shouldn't be too surprising to us. I mean, we're kind of used to maps like this. This is not a full-size rendering of the real world, but it's a very useful one. In fact, that's where we are right now. So Google Maps has been doing this for a while, but I think we take some solace in the fact that this was created by a satellite flying a mile over our head. Things are going to get much more detailed. But how do we see it? So right now, we primarily experience the mirror world through AR or XR devices. And I'm going to take 1 second to kind of go through the alphabet soup of VR versus AR versus XR, because even I get confused by this sometimes. So when we're talking about VR, we're talking about virtual reality. And that's when you disconnect from your physical world and you enter into a virtual one to have an experience. This is me playing Beat Saber in virtual reality, which is kind of like Dance Dance Revolution with lightsabers. It's really a lot of fun. And believe me, I am completely oblivious to the world around me. I don't care that I look like a fool. I'm having fun. Augmented reality is when you are layering digital information on top of the physical world for utility. So the digital and the physical coexist, but they aren't really impacted by one another. So this is like virtual wayfinding. I can look at this street and it can give me labels of what those stores are, but it doesn't really matter that the labels know what's on the street. Mixed reality, this is one that's getting a lot of play. So XR stands for mixed reality or extended reality. Microsoft still uses MR, but essentially it's the same thing. If you see XR, what that's referring to is when the digital objects you see react to the items in the physical world. So this picture is an example of a program called Project Vita that's being done by the Dan Marino Foundation. And they created this simulation to help people train at being better in interviews. So this woman is sitting in a chair. She's looking at a blank chair across from her. But what she sees is this guy. There's an avatar that's aware of the chair, aware of the table, and more importantly, can look that woman right in the eye to help her be a better interviewer. So this is a great example of those two worlds being aware of one another. That's XR. Okay, so back to the mirror world. How are we using this mirror world concept? How is it making our lives better? Google actually has a product in beta right now as part of Google Maps. It's called Google Maps AR. And what they're trying to solve is the problem of using Google Maps in a city with really tall buildings where you can't get a really good location on where you are. Your little blue dot bounces all over the place when you're trying to get directions. So what they've done is they've taken all the information they have in Street View, and they've partnered it with Google Maps so that when you're in a city, you don't have a great signal, you hold up your phone and you turn on the camera. And it actually looks at the buildings, scans the buildings in that mirror world, and gives you a much more accurate position of your location. They've also coupled this with street finding and indicating. I travel to a lot of cities, and I'm shocked at how many intersections have just no street signs on them. So I'm particularly looking forward to this one a lot. Now, they are thinking about safety. Google does not want you walking around with your phone up in front of you into traffic. So this actually only works when you're standing still, and then they tell you to put your phone back and continue on your trip. You can't play with this just yet unless you happen to be a Google local guide. Anybody in the office? You are going to be invited to get early access to this, which is going to be really cool. And the last example I want to give of the mirror world is what Microsoft is doing with their HoloLens. So when Microsoft first came out with their HoloLens product, they demoed it with like giant Minecraft simulations and aliens popping out of walls and shooting them with lasers. And as a gamer, I thought that was really fun. But they've pivoted recently to go much more at industry with this product. And what you're seeing right now is because the mirror world of this warehouse has been mapped into the HoloLens, this worker can look up at the rack and and see how many things are on that pallet and where she needs to take them. This is also going to be really great for learning. This is a new worker who's got a HoloLens on and is learning how to put together an engine with annotated instructions right on top of the engine. That's pretty cool. And if she gets stuck, she can just hit a button that pulls up a live chat with her supervisor and gives her one-on-one instructions. So the challenges with the mirror world, there's going to be a few. Once again, privacy. So in order for the mirror world to come into existence, this one-to-one digital world all around us, we need cameras everywhere scanning everything. That sounds like fun. This is Newark Airport. This is a gate, the United Gate at Newark. There's all these free tablets everywhere for anybody to use while you're waiting for your flight. They even have them at the bar. What does every single one of those tablets have on it? A camera that's not covered. Are they using these to create the mirror world? I don't know, but they probably should if they can get around the legal parts of it. Safety is another concern. When we have digital overlays in front of our field of vision, how are we going to make sure that we're being safe about it? So this is a sign reminding people on the highway, do not Pokemon Go and drive. So just recapping the mirror world, there's an invisible dimension of data being constructed at a one-to-one scale all around us. It's here. AR and XR devices are going to let us tap into this world to make use of it, and directions and training, I think, are just the beginning. And we, as marketers, are going to be tempted to go too far, probably us, no, and turn every surface into an ad. Let's not do that if we can help it. This is an example of a video called Hyper Reality. If you've never seen this, you need to Google it after the event today and watch it. It kind of presents this future world of when every single surface, even things that aren't a surface in our field of vision, become opportunities to message us. And I won't give away the ending of this, but it's worth watching till the end. So just to conclude, the digital world that we've been talking about today that's been made possible by faster, cheaper math from the middle of the 20th century is maturing. And we're all learning to deal with that and the changes that it's brought about, those headwinds that we've been talking about. We are in the process right now, looking into the future, of realizing faster connectivity, better and cheaper predictions, and the complete digital mapping of our physical world. So I want to go back to Quantum Leap for a second. In the final episode of Quantum Leap, Sam met God. That's what God looks like, in case you were wondering. And God told Sam that he did a really good job in correcting all the mistakes from the past. But he also told him that his leaps were going to get tougher. I think that the challenges that we're going to face in the future are going to be both more exciting and, yeah, probably tougher. But we are, as an agency, we're investing in those curious mindsets who are going to be eager to help us figure out what's next. So I wanted to bring that back up one more time. Thank you guys very much. Okay.